long time. I can do my long time calculations. So let's do our long time calculations, and let's redraw for t less than 0. Keep track of the time, so we're running out of time, so you have enough time to take your quiz. All right, I think we have a while yet. Here we go. We're going to redraw for t less than 0. I have, this switch was open. All this stuff to the left isn't really important to me for that. I have the inductor. How's it behaving?
Close.
It's like a short circuit. All right, good. Here is IL at 0. Then I have a resistor. And a resistor. And a resistor. And a current source. And a wire, and that one, well, that's a wire, that's a switch, and it is closed for t less than 0. Pretty clear on that. Okay. This is 3 ohms, 9 ohms, 6 ohms, 8 amps. I'm solving for that current. Let me remind you, this is what we're going to do over and over again. What have we just done? We've converted it into a chapter 1 through 4 problem. The inductor's not there, so we can solve it. Okay, question.
Could you remove the top part of that?
I'm sorry, say that again, nice and loud.
The top part of that.
I'm still not hearing your words. Say it. Wait till I stop talking, and then you start talking and do it loud. Now.
The part with the 8 amp current source.
Yeah.
That top part, can you ignore all of this? This is parallel with the 0 value current source.
Oh, there's a great question. Well, can I?
Yes.
He says yes. He says yes. Sounds like we have a consensus here. What would that mean?
That its current is 0, IL is 0 is 0.
It's going to be 0. You're suggesting we can do this like that. And you're right. We can do this like that. Good catch. All right. Yeah, this is by inspection. Now, I'd like to point out, you can also write 4 mesh equations. And you will get the same answer. A long time after he does, you'll get the right answer. It's okay. It's not great. The other alternative is to apply something like Kirchhoff's current law down here. There's one of the currents. What's that current? It's 0 because there's a wire across that 3 ohm resistor, right?
Yep.
How about the current through the 6 ohm resistor? It's a 0 because
Could be in series with the short end we take out.
being in series with the short is not the point. What's the point about the 6 ohm resistor?
Oh. Surrounded by a wire.
It's got has 0 volts across it. It's a big long wire. We don't care. There's a wire across it. Which means you got 0, which is the answer he got even faster. Mesh current method. It works. You get 0. Source transformations. It works. Your answer is twice, and Kirchhoff's law, all of them result in the same answer, IL at 0 equals 0. Question?
If we had something like that on an exam, would we need to still do a drawing for t less than 0?
I'd like a drawing.
Okay.
I'd like a couple more words.
Okay.
I'd like, listen carefully, I'd like a couple more words at least. That's more than a couple. By the way, a couple in where I grew up means 2. Other places, a couple can mean 3 or 4. That looks like 6. All right, you don't need that many words. Parallel voltage source really would have been enough. 3 words. I'd like to hear something before you write that. I'd like to see something, so I know what you're doing. Okay? All right. You're gonna have to find 6 things. We've got 1 of them so far. You're gonna finish. I don't know if I'm gonna finish or not. I'm gonna start. We'll see how well I do. But we found the first thing. Then, what's next? I need a time constant for the first time period. I'm going to redraw for 0 less than t less than 1 second. Okay, so listen, this is important. Not equal. Second, I want to see units here. Got a lot of points? That's 1 point, but don't throw it away. That's a number, it's an important number, it's associated with a diagram. I want to see a unit. Draw the circuit. All right. In this time period, that switch is closed, so this part of it now matters. So I have this circuit. Voltage source, 10 volts. Resistor, 2 ohms. Resistor, 3 ohms. Resistor, 0.8 ohms. That's a weird value. Dr. Nielsen picked that to make the numbers work. The inductor. It's inducting in this time period. Draw it as an inductor. 2 Henrys. LA. 2 Henrys. Then 3 ohms. And look, he already gave us a hint that 9 ohm and that 8 amp current source, they are both in parallel with a voltage source. They can be neglected with respect to things outside that parallel combination. But these things, the 3 ohm and the 6 ohms, they're not in parallel with that 0 valued voltage source. I need to keep them in. You ignored them over there. Well, that was a different circuit over there. That circuit and this circuit are not the same. All right, what are we looking for? We're looking for I sub L. Here it is. What are we looking for now? We're looking for the time constant. How do we get that? The equivalent resistance seen by the inductor for this circuit. How do we get that? Take out the inductor. And then kill the independent sources. Kill the independent sources. Do you need to redraw this circuit to then find the resistance? Or can you do that in your head? The answer is, I don't know what the answer is. You'll have to decide that. If you're having any doubt, so here's the test that I want you to go through in your mind. If you're trying to do this in your head and you're having trouble, stop trying to do it in your head and draw the circuit. It doesn't take that long. Now, if you can do it quickly and easily, there's no reason to spend any time. But if you're having any trouble at all seeing what's in series or parallel with anything, it doesn't take that long to draw it. Does anyone have a stopwatch right with them right now? Time me. Start, say go, and I'll begin. Take the inductor out. 0.8 ohms. 3 ohms. 2 ohms. Independent source gets killed because she told me to. 3 ohms. 6 ohms. Stop. 45 seconds. I will tell you, I watch students taking exams and quizzes. They'll be staring at something for 2, 3, 4 minutes. If you're spending 4 minutes to save 45 seconds, you're wasting time. How do you do it without drawing this? Of course. You can immediately write it down. Don't redraw it. Redrawing the circuit is not something to be afraid of, and generally speaking, it's not that much time. I need to sell this because I know this is a counterintuitive notion. In fact, I didn't really believe it until one of my heroes, Professor Snyder, who I watched teach this course for a number of semesters, he would always advocate, draw the diagram, it's faster. And I thought to myself, no it isn't. And the answer is yes he is. Yeah, he's right. It's faster. How is it faster? It's faster if it lets you think clearly. Thinking clearly is the hardest thing to do on these exams. And it's what I most want you to do. And the diagrams help you do that. I look at this diagram and I can say to myself, those two are in parallel. Which is in series with point 8. And that's on that side. On the other side, I have 3 ohms and 6 ohms in parallel. Say again, say it loud. What happened to 9 ohms? He gave us a hint. He said anything in parallel with a voltage source can be ignored when I'm looking outside the parallel combination. That switch is closed, which meant that wire is in parallel with the 9 ohm resistor. It's going to come into play the next time period. Right now, don't need it. Okay? this in my head. 3 in parallel with 6, that's a common thing, and it's product over sum. 18 over 9, that's 2 ohms. 2 in parallel with 3, that's 1.2. 1.2 plus 0.8 is 2. 2 in parallel with 2 is 1 ohm. It's got to be a Dr. Nielsen problem. Okay. Don't expect the numbers will ever be that nice when I design it. But there it is. Which means the time constant is pretty easy. Tau, which is equal to LA over R equivalent, which is 2 henries, 1 ohm, which is 2 seconds. You've got a time constant. What else do we need? We need the steady state value for t between 0 and 1 second. Here's the way I'd like you to refer to this. Say, steady state for 0 less than t less than 1 second. That's the way I'd like you to write it. And then draw the diagram, which is what? It's that diagram there with the inductor as a short. The rest of the circuit is in parallel with the short. There are resistors with 0 volts across them, therefore 0 current through them. I replace them with open circuits. And I have 2 ohms, 3 ohms, 0.8 ohms, and I'm looking for this current. It's really the steady state value that I'm looking for. I don't know. I actually think I'd probably use mesh currents here. It's going to be nice and quick. 2 equations, 2 unknowns. One of the 2 equations will be the one I want. Or I combine these 2 in parallel and I get this voltage, and then you divide that voltage by that resistance and I get that current. Or I don't know, you pick something. No voltage method. One equation gives you the same voltage, and then use that with the resistance to get the current. I don't care. Solve it. You get a number. Let's pretend it was 3 amps. That's unlikely, but who knows? I don't care. Let's just pretend. If it's 3 amps, your next step is to write IL of t is equal to that value. In fact, I'm going to put units all together at the end, so we'll leave it off here. Three plus the initial value minus the final value, e to the minus t over the time constant. Promises to put the units in. There they are. And then give us the time of validity. Okay? Questions? Next, I I need the initial condition for the next time period. So, I take the inductor and replace it with a short circuit. No. That gives me the initial value. Plug in the time of switching and find it. That looks weird, but my calculator can handle it without any trouble at all. And a number pops out. I don't think even Professor Nielsen can make that number nice. He tries, but that's going to be a number. Like all the other numbers we really encounter in real life. A number. 2.15, I don't know what it'll be. It'll be something. It's a number. That's the initial condition. And then what do I do? I redraw for t greater than 1 second. And I go back to the original circuit, and that switch is opened again now. And the inductor is inducting, still inducting. And I have a resistor here, and a resistor here, and a resistor here, and a current source which now is not negligible anymore. 8 amps. 9 ohms. 6 ohms. 3 ohms. 2 henries. Current here, IL. And what do we do here? Find the equivalent resistance seen by the inductor. How do we do that? Take the inductor out. Set the independent source equal to 0. Get 15 in parallel with 3. It's going to be 2 point something. Divide that into 2 henries. We're going to get a time constant. Then what are we going to do? We're going to redraw for steady state for t greater than 1 second, which means this is going to be a wire, which means I'm going to have a current divider rule. This resistor will have no effect. It'll be the current through the 6 ohm resistor. It'll be current divider rule. It'll give me a current. I have an initial value, a time constant, a steady state value. I load them into my new equation. My new equation is going to have a t minus 1 second in the numerator and a new time constant, a different time constant in the denominator. It's going to have a new initial value, a new steady state value, and it's going to be valid for t greater than or equal to 1 second. Questions? Good. Next time I want to work a problem with you again, but right now, let's take a quiz. Let's play the old-fashioned